Very good morning. In the last lesson, I have discussed the exponential function and logarithmic functions and how to find out the differentiation of logarithmic functions and exponential function. And today, in this lesson, I am going to solve some of the problems. Suppose you have find the differentiation of e to the power x upon sine x. E to the power x upon sine x. Can I write let y is equal to e to the power x upon sine x. There are two functions, f and s. First function, second function. Therefore, differentiating with respect to x, we get dy by dx is equal to differentiation of first, second as it is, and with sine x into d by dx of e to the power x minus e to the power x into d by dx of sine x whole divided by sine x whole square. It will give you e to the power x into sine x minus e to the power x, difference analysis cos x divided by sine x square x, which I can write e to the power x common sine x minus cos x whole divided by sine x square x. Right? E to the power x sine x minus cos x by sine x square x is the differentiation of e to the power x upon sine x. These are the questions of exercise 5.4. Now, suppose the one question is sine tan inverse e to the power minus x. The question number is question number 4th. Sine tan inverse e to the power minus x. Right. Let y is equal to sine tan inverse e to the power minus x. Differentiate with respect to x both sides. Dy by dx is equal to differentiation of d by dx of sine tan inverse e to the power minus x, and that is equal to differentiation of sine x is cos tan inverse e to the power minus x. Now differentiation of tan inverse e to the power minus x. This will give you cos tan inverse e to the power minus x into differentiation of tan inverse x. Differentiation of tan inverse x. 1 upon 1 plus x square. Here, in place of tan inverse x, we have e to the power minus x. That is e to the power minus x whole square. That is e to the power minus 2x, can I write? And after that, differentiation of e to the power minus x. Right? Now, can I write cos tan inverse e to the power minus x whole divided by 1 plus e to the power minus 2x into differentiation of e to the power minus x, e to the power minus x into minus 1, because here it is minus x, and therefore differentiation of minus x will have minus 1. That's why can I write now this whole answer as minus e to the power minus x into cos tan inverse e to the power minus x whole divided by 1 plus e to the power minus 2x. This was question number 4th. Right? Now, question number 8th. 8 we have find the differentiation of log of log x. So let y is equal to log of log x. Differentiating with respect to x, both the sides, dy by dx is equal to differentiation of d by dx of log of log x. Now, differentiation of log x is what? 1 upon log x. So now 1 upon log x. Differentiation of log x is 1 upon x. Okay. Here, log in place of x we have log x. That's the 1 upon log x into d by dx of log x. And therefore, differentiation of log is 1 by x. So now I can write 1 by x log x. 1 upon x into log x, right? Now question number 9. Let y is equal to cos x upon log x. Cos x upon log x. Now differentiating with respect to x, we get dy by dx is equal to d by dx of cos x upon log x. Now here there are two functions, cos x and log x. That's why we'll apply the rule for quotient rule. Cos x upon log x. First function and the second function. Now can I write dy by dx is equal to differentiation of first, second as it is, log x into differentiation of cos x minus cos x into differentiation of log x whole divided by a square of the denominator, that means log x whole square. This can write now dy by dx is equal to log x into differentiation of cos x is minus sin x minus cos x into differentiation of log x is 1 upon x whole divided by log x whole square. Remember this part now? Now dy by dx is equal to write minus sin x into log x minus cos x by x whole divided by log x whole square, which I can write minus x into sin x into log x minus cos x whole divided by x and divided by log x whole square. Log x whole square. If I take common minus, x sin x into log x plus cos x whole divided by x into log x whole square. This is the differentiation of this function x log x sin x plus cos x whole divided by x log x whole square. Now if I go for the next exercise, that is 5.5. In the 5.5 mainly we have to use the logarithmic functions, right? The first question is find the differentiation of cos x cos 2x into cos 3x. Cos x into cos 2x into cos 3x. let y is equal to cos x into cos 2x into cos 3x. See, if you apply log, it will be easy. Then you write taking log both the sides. Taking log both sides. Log of y is equal to log of cos x into cos 2x into cos 3x. Now, log of y is equal to, here we will apply the formula log m into n into p is equal to log m plus log n plus log p. That's why I can write now this is equal to log cos x plus log cos 2x plus log cos 3x. Right? Now differentiate with respect to x. Now differentiation of log y. Now I am not writing d by dx. Now differentiation of log y is 1 by y into dy by dx is equal to differentiation of log cos x is 1 by cos x into differentiation of cos x is minus sin x plus differentiation of log cos 2x is 1 upon cos 2x into differentiation of cos 2x is minus sin 2x into differentiation of 2x will have 2, can write here now 2 plus differentiation of log cos 3x is 1 upon cos 3x into differentiation of cos 3x minus sin 3x minus sin 3x into differentiation of 3x will have 3 into 3. Therefore, now it becomes 1 by y into dy by dx is equal to minus sin x upon cos x minus 2 sin 2x upon cos 2x minus 3 sin 3x upon cos 3x. But we are asked to find out the value of dy by dx. Still 1 by y is there on the left hand side. That's why what I will do, I will carry this part on the right hand side. Right? That means now dy by dx is equal to 1 by y will go on the right hand side, it will become as a product. And y is equal to what? Cos x into cos 2x into cos 3x. Therefore, can I write now dy by dx is equal to y into minus sin x by cos x. Can I write minus tan x minus 2 sin 2x by cos 2x, can I write tan 2x, and this I can write 3 tan 3x. Can I write? Now, put the value of y. The y is cos x into cos 2x into cos 3x multiplied by minus tan x, or take on minus here and write here tan x plus 2 tan 2x plus 3 tan 3x, and this will be the answer. Isn't it? Minus cos x into cos 2x into cos 3x multiplied by tan x plus 2 tan 2x plus 3 tan 3x. Right? Now, the next question. The second question is find the differentiation of y is equal to, let y is equal to under root x minus 1, x minus 2 whole divided by x minus 3, x minus 4, x minus 5. Right? This is actually y is equal to x minus 1, x minus 2 divided by x minus 3, x minus 4, x minus 5 whole raised to the power 1 by 2. Right? Whole raised to the power 1 by 2. Right? Now, if I apply log both the sides, then I write here taking log both sides, log y is equal to log of x minus 1, x minus 2 upon x minus 3, x minus 4, x minus 5 whole raised to the power 1 by 2 log m to the power n. You remember what? Log m to the power n is equal to n log m. That means this half will bring and will come on directions here. Log of y is equal to half log x minus 1, x minus 2 upon x minus 3, x minus 4 and x minus 5. And now here half log. Now again apply the formula. Log m upon log n. And log m upon log n is equal to log m minus log n. Log m minus log n. So now see what we will have. Log of y is equal to half into log m x minus 1, x minus 2 minus log x minus 3, x minus 4, x minus 5. Log m minus log n. Right? And when we apply this log m minus log n, then now see all the three formula we are going to apply over here. First was log m to the power n, then log m upon log n. Now here log of m into n minus log of m into n into p. And log m into n is equal to what? Log m plus log n. Therefore now what can I write? This becomes log of y is equal to half in bracket log m into n, that is log x minus 1 plus log x minus 2, log m plus log n, right, minus log m, log n, log p. And with plus sign here being minus, I write with all terms with a minus now. So now minus log x minus 3 minus log x minus 4 minus log x minus 5. See, now we have applied all the three formula of logarithms, isn't it? That means log of y is equal to half log x minus 1 plus log x minus 2 minus log x minus 3 minus log x minus 4 minus log x minus 5. Now we will differentiate. Now differentiate with respect to x. Log of y is 1 by y into dy by dx is equal to half. Log x minus 1 is what? 1 upon x minus 1 plus 1 upon x minus 2 minus 1 upon x minus 3 minus 1 upon x minus 4 minus 1 upon x minus 5. Right? But I have to find out dy by dx. That's why dy by dx is equal to y into 1 by 2 into 1 upon x minus 1, x minus 2, x minus 3, x minus 4, 1 upon x minus 5. Now put the value of y. Put the value of y. Y is what? The value of y is, from the question directly, now dy by dx is equal to 1 by 2 into under root x minus 1, x minus 2 upon x minus 3, x minus 4, x minus 5 into under root, without that, 1 upon x minus 1 plus 1 upon x minus 2 minus 1 upon x minus 3, x minus 4. Here you can also take the LCM and you can solve further, but no need to do solve it. Right? See, using log it becomes very easy. Otherwise, it would have been difficult. Now, I'll do the third question. Find the differentiation of log x to the power cos x. Log x to the power cos x. That is question number 3. Log x to the power cos x. Right? Let y is equal to log x to the power cos x. Taking log both the sides. Log of y is equal to log of log x to the power cos x, applying log both the sides. Get it? What will we get now? Cos x. Therefore, log y is equal to cos x into log of log x, applying log both the sides. Isn't it? That means log y is equal to cos x into log of log x. Now here there are two parts. First product, first function, second function. Here it is log y. Now we'll go for differentiate with respect to x both the sides. Log y 1 by y into dy by dx is equal to differentiation of the first second derivatives, that means log of log x into differentiation of cos x plus cos x into differentiation of log x. 1 by y into dy by dx is equal to differentiation of cos x is minus sin x. So now minus sin x into log of log x plus cos x into differentiation of log x is 1 by log x. Again, differentiation of log x, log of log x, that is log x, 1 by x, that is 1 by log x. Differentiation of log x is 1 by x. Right? Therefore, what we will get now? 1 by y into dy by dx is equal to minus sin x into log of log x plus cos x upon x log x. We'll go one line ahead. Because see, dy by dx, therefore dy by dx is equal to y into this y on the right hand side, y into, first I write the positive terms over, cos x upon x log x minus sin x into log of log x, right? But this answer doesn't suit, no? That's why I'll go for one or two more line, or we can leave it here also, that is cos x upon x log x minus sin x into log of log x. But better it should go one or two more, because here simply it doesn't look nice. Therefore now can I write the value of y? Y was log x to the power cos x. Log x to the power cos x, and LCM is here x log x, and therefore I write now cos x minus sin x into log of log x into x log x. I'll write here x here, and log x is there also, therefore I'll write here log x. So now cos x, x log x is the same, cos x minus x sin x log x into log of log x. Now this we write as the answer. Fine. Similarly, you can do almost all the questions of this exercise, and suppose now one question is question number 4th. In the question number 4th, we have find the differentiation of x to the power x minus 2 to the power sin x. X to the power x minus 2 to the power sin x, right? Here there are two functions, variable on variable, constant and power is variable. That's why we cannot differentiate easily. Actually what we will do, we will find this part, this whole questions in two functions as u and v. That means can I write that let x to the power x is equal to u and 2 to the power sin x is equal to v. That is, you have two functions u and v. Therefore, can I write now let y is equal to x to the power x minus 2 to the power sin x is equal to y is equal to u minus v. And actually what I have to find out? We have to find out dy by dx. That means we will differentiate both the sides, right? That is the whole functions differentiate. I find out dy by dx is equal to du by dx minus dy by dx. It means what? I have to differentiate this function u with respect to x, differentiate this function v with respect to x, where u is taken as x to the power x and v is to the power sin x. That's why now first we will differentiate both the parts separately. First of all, we will go for u. U is equal to x to the power x, taking log both the sides. Without log we cannot do. Why? Because here x to the power not a constant is there. Here x to the power x, variable is there. That's why we have to take log, and without log we cannot solve it. Please remember. Now here log of, taking log both the sides, log u is equal to log x to the power x, log x to the power x. It becomes what? X log x. It becomes x into log x. Now differentiating with respect to x. Log u 1 by u into du by dx is equal to differentiation of x is 1 log x as it is plus x as it is, differentiation of log x is 1 by x, right? This x and x is cancelled. Therefore, now it becomes 1 by u into du by dx is equal to 1 plus log x, can I write? And it implies that du by dx is equal to u on the right hand side will go, and the u is what? X to the power x. Therefore, x to the power x in bracket 1 plus log x. This is the value of du by dx. See, this part we have derived. The value of du by dx is x to the power x in bracket 1 plus log x. Now we'll find out the differentiation of the second part, which I have assumed as v. Right? Now v. Now v is equal to 2 to the power sin x. See, if I would have sin x to the power 2, that was not a big problem, but here 2 to the power sin x, if you remember, a to the power x, isn't it? That means, can I apply both sides log, or we can go for without log also, because you know that the differentiation of a to the power log x, a to the power log x will have what? A to the power x into log x, right? Therefore, this part we can do without taking log also, right? And if I take log, then also there is no problem. Then it becomes log to the power sin x, it becomes sin x into log 2, where log 2 will be the constant. That's why, can I write now dv by differentiating both with respect to x, differentiating both sides with respect to x. dv by dx is equal to, I am applying here d by dx of 2 to the power sin x. I am applying the formula d by dx of a to the power x is equal to a to the power x into log a. Now tell me what will happen. dv by dx is equal to differentiation of 2 to the power sin x, 2 to the power sin x into what? Log part is there, no? Log 2, constant term. Here in place of a, what we have? 2. That's why log 2. Now 2 to the power sin x. Now what is left out? Differentiation of sin x is left. Clear? So now d by dx of sin x is the formula. d by dx, differentiation of a to the power x is a to the power x into log a. So d by dx 2 to the power sin x, 2 to the power sin x as it is, differentiate into log a. In place of a we have 2, that's why log 2 into differentiation of, now this is not simple x, this is now sin x, that's why differentiation of sin x will write. Therefore now we will get here d by dx is equal to 2 sin x to the power sin x into log 2 into difference sin x will be what? Cos x, which simply we can write this is equal to log 2 into cos x into 2 to the power sin x. This is the differentiation of the second part, and that's why now we will come to the final part of this answer of this question, that dy by dx is equal to, therefore finally dy by dx is equal to, initially I have written that dy by dx is equal to du by dx minus dy by dx. Here we all have calculated the both the parts, and then we will write the answer. The first dy dx, we have written that x to the power x in bracket 1 plus log x, this is dy dx, minus log 2 into cos x into 2 to the power sin x, and this is the answer, right? X to the power x into 1 plus log x minus log 2 into cos x into 2 to the power sin x. Just 1 minute I will take. If this question, this part, if I would have taken like this, v is equal to 2 to the power sin x. Now if I take log both the sides, what will have? Log of v is equal to log to the power sin x, it becomes sin x into log 2. Here log 2 will be taken as constant. That means now log v, differentiating both the sides with respect to x, what will we get? 1 by v into dy dx is equal to differential of sin x is cos x, that means cos x into log 2. Now dy dx is equal to this v, you will go on the right hand side, becomes 2 to the power sin x into cos x into log 2. See the earlier what we have done, dy dx is equal to 2 to the power sin x into cos x into log 2. The answer is here same, but maybe sometimes when we differentiate with the another rule, another part, another formula, maybe sometimes we get the different answer. Here in this questions we are getting the same answer, right? That's all for today. I hope, please you yourself keep on doing all the questions, and before going for the exercise I'll advise you to do the questions of the examples also, so that we'll have the complete idea how to write and how to go for the solution. Thank you very much. Have a nice day. Take care of yourself and do well. Thank you very much.